Hi, I'm Ria,
I'm Grace.
I'm Jenny.
and welcome to our virtual lesson on two-dimensional arrays. Simply put, a 2D array is an array of arrays, but another way to think about it is this. Suppose you want to access the nth element from a 1D array. You would start iterating over the array using an index. When the index is at n-1, you retrieve that element, and then retrieve and read the values. In a 2D array, instead of accessing the element using one parameter, you have two. Hence, it is two-dimensional. Instead of accessing the nth element, you would access the element in the nth row, and then the nth column, and then you sort through two indices. 10.1 Introduction to 2D Arrays. In Java, or in general programming, arrays store data of the same type. For example, in a 1D array, all the elements would be strings, characters, integers, booleans, etc. This is no different in a 2D array. All of the elements are of the same data type. 2D arrays are organized in rows and columns, making the two dimensions. Because of this, 2D arrays are especially useful in scenarios when data is naturally arranged in rows and columns. Examples include spreadsheets, game boards, or even seating arrangements, like in our scenario. Each student has a row and a seat number, which are the two parameters that are used to access each element, suppose the location of each student. By sorting, we can get this kind of information about a given student, like which student is at which location. 10.2 Array Storage. 2D arrays are stored in the form of 1D arrays. There are two common ways of storage, row major and column major. In row major, the data is stored by rows, and each row contains an array of columns. For column major, it's vice versa. So data is stored by columns, and each column contains an array of rows, or in other words, the information for each column. How Java stores 2D arrays. Like I mentioned earlier, the best way to describe storage is like an array of arrays. Outer arrays reference inner arrays. So for example, in row major arrays, the rows are the outer arrays and the columns are the inner arrays. An important thing to note is that indices start at 0 and end at the length n-1, as they do in one-dimensional arrays. This is why we would access the element a at the index a-1. It is conventional for 2D arrays to be row major. If unspecified, assume that they are so. Ragged arrays are arrays with inner arrays of different lengths. If you visualize an array and think of it like a grid of blocks, this makes more sense. If each inner array, or column, is of a different length, you will end up with a ragged shape or a ragged edge, hence the name. 10.3.1 Declaring 2D arrays. Like I mentioned earlier, the data type must be consistent throughout the array. This must be specified by first writing int, boolean, string, etc. Then you must add two sets of square brackets to represent a 2D array. 1D arrays are represented by one set, so add a second one to represent that second dimension. So far, these declarations have named the variable, but not actually created the array. It is analogous to this example. If you write int n, you have created a variable of type integer, but you have not assigned a value. So to do this, you must write new, and then specify the data type, for example, new int, and then input the number of rows and columns to set the size of the 2D array. It is important to note that the size of the array, or the total number of elements, is the number of rows times the number of columns. This makes even more sense when you refer back to that mental visual of the 2D array from before.
So for setting values in 2D arrays, the contents of an array are going to be automatically initialized when you first create it. So in Java, that would mean 0 for an integer, null for an object, and false for Boolean types. So to set a value at a specific position, you need to type in the name of the array and the row index in brackets, as well as the column index in brackets. Then you set the position equation to a new value. It is also possible to initialize values for the array when creating it. So in the example here, each inner set of brackets represents the elements in a row. It's actually very similar syntax for getting a value of a 2D array to setting a value. So you use the name of the array immediately followed by the position in the brackets. So in this example, we have string best student, and it's going to be equal to seating chart and the following position, the row and the column. For getting the number of rows and columns, there's actually a built-in method in Java to find the length of any array. So the method is arrayname.length. And to find the number of columns, you would simply need the length of the values inside a specific row. So that is why we're going to be using the brackets and the index 0 for the number of columns in the first row. As for looping through a 2D array, to loop through a 2D array, we need to use a nested for loop. A nested for loop has multiple loops inside of the other. And the first loop can cycle through the rows, and the second can cycle through the columns in each row. So the example below shows a nested for loop, which is basically a for loop inside a for loop. As you can see, it is cycling through all the rows on the first line, and on the second line, it's cycling through all of the columns and then printing out each of their values. So n is equal to number of rows, and m is equal to the number of columns.
10.8. Use a for each to loop through a 2D array. So just like with the 1D array, we can also use a nested for each loop to loop through each of the inner arrays in a 2D array. If you look at the code below in blue, it says that for each element in the inner array, which in this case would most likely be a row, and then for each value in the inner array, you would add a number to the number of total students. This way we would be able to count the total number of elements in an array. Now for 10.9, loop through part of a 2D array. This part is actually really simple because all you have to do is change the starting and ending values inside of the loop. So you would no longer start at index 0, you would start at a random value that you would pick. That would be less than the length of the row or the column. And then finally, we have some common mistakes with 2D arrays that you have to be sure to avoid. First of all, people often forget to create the array and they only declare it. So if you go back to 10.2 or 10.3, you would find that it's actually important that you have the new array name and then use the 2 brackets to declare the array and actually create it. Another point to remember is that indexes always start at 0, not 1. So the last element in the array would actually have an index of n-1, not n. Array, like the point below, array at index 0.length is not the last index. And a very common error when using arrays is array out of bounds exception, which means that the index end or start is incorrect. It's very common if you accidentally miscount and you're trying to loop through part of it instead of looping through the entire array. Jumping out of loops before completing. If you use continue or break, you have to make sure that you're using the right one. When you break out of a loop, you will not enter the loop again, but if you continue, it'll just continue on with iteration. It won't break out of the loop. So be sure about that. And then finally, array length versus array at index 0.length for the number of rows and columns. Array.length will give you the number of rows, while array bracket 0 bracket .length will give you the number of columns. And that's all. Thank you guys for listening to our lesson on two-dimensional arrays.